We've made our way over, not quite the distance that Chandra went, but we made our way over across the studio to talk to Wallace Tucker. He's a astrophysicist and the author of a new book from the Smithsonian books, all about Chandra's Cosmos. Wallace, welcome to the new screensaver.
Thank you. Glad to be here.
I got a little confused because I didn't realize this. We all know Hubble. That's the best known space telescope. What I didn't realize is that when NASA launched Hubble, they were working on a total of 4 space telescopes.
That's correct, yeah.
So what was the difference between Hubble and Chandra?
Hubble is sensitive to visible or optical wavelengths, and so that means it's sensitive to stars, which typically have a temperature of 10,000 degrees to 20,000 degrees.
It's not an accident. It makes sense that we would be able to see
star. That's right.
Right. Yeah. Otherwise, we'd go walk around the Earth with that bumping into things. Yeah.
And Chandra is sensitive to gas that's got temperatures of millions of degrees.
Oh, interesting.
And so it's a big difference in that respect. And when they tried to launch the first X-ray telescope, there's a lot of skepticism. You're not going to see anything.
Right.
Well, what they found out is that most of the matter, the normal matter in the universe, is hot.
Right.
It's at millions of degrees. So Chandra and other X-ray telescopes have uncovered where most of the matter is. And of course, that I'm saying normal matter because that gets us into the question of dark matter, which we don't, it's definitely not normal, but there's more of that than anything else. So
here's our Milky Way. And actually, these are some beautiful images. This is the center of the Milky Way. It's almost 500 light years across here that we're looking at.
The center is almost 500 light years, and the Milky Way is, of course.
So you're seeing some. What do we learn from these X-ray images that we didn't learn from visible light?
As I said before, you're seeing the hot face of the universe with Chandra, and some of the X-ray photographs, you'll see a shock wave that's going millions of miles an hour, and it produces this hot gas. It's simply not visible with the optical telescope.
Is that the result of a nova or
a supernova, an exploding star? Right. And turns out that not only do stars explode, galaxies, the black holes in the center of them can produce explosions which go over thousands and even millions of light years and produce, again, hot gas that you can only see with a telescope like Chandra.
So has Chandra found some black holes?
It's found more black holes than any other telescope in history. And there was one project which was fascinating. You may be familiar with the Hubble Deep Field, where they just stared at one place for a long time. Well, they did the same thing with Chandra. They picked a field where, as far as they knew, there was nothing. They said, we're just going to stare at that field for weeks and months. And they found thousands of black holes out there. Yeah.
You don't see a black hole because there's no light emerging from it. What do you see if you're looking at a black hole?
You see, you detect them because matter is falling into the black hole. And as the matter falls in, think of swirling down the drain of a bathtub. As it swirls around, it goes faster and faster, and the friction gets so great that it heats this material to millions of degrees, and it gives off X-rays.
So it's like Wizard of Oz. You see like houses going down there and stuff.
Same thing.
There's some amazing images of black holes in here, including something called a green black hole. I don't know why it would be green. These are not, in order for us to see these pictures, they have to be adjusted, right, to the lights.
They come in as digital information, and then they transform that into an image, because there's position and energy characteristic of each bit that comes in, so they can reconstruct it to an image.
Is there something they're hoping to see from that they haven't found yet, that they're aiming to see?
Yeah, I divide the book into the big, the bad, and the beautiful, and in each case there's something that they really want to find. Like the big is the largest objects in the universe, and they would like to see just how large they are. There's galaxy clusters of thousands of galaxies, each one with trillions of stars. They'd like to know where these end. They haven't really seen the edge of those. And then they really haven't been able to detect or understand what the dark matter is. They'd like to know what that is. That's one of the major emphasis and targets of Chandra, is to find that. Then they'd also like to understand the black holes. And you referred to green black holes. We called them green black holes because they recycle matter. The matter comes into the black hole, and this was a discovery that Chandra played a very important role in. They thought before the matter falls through a black hole, all of it's going to go in. Well, it turned out that not all of it goes in. It's like if you notice that when the matter swirls into the water goes into the drain, some of it bubbles. It can't get in fast enough, and that's what happens with black holes. It's really twisting magnetic fields and shooting jets of particles at near the speed of light back out into the galaxy. Maybe 50, maybe 70 or 80% of the matter gets recycled, and then it helps to form new stars and things like that.
There's also an infrared telescope.
Spitzer, yeah, telescope.
And that's at the other end of the spectrum.
That would be beyond Hubble in terms of its infrared, so it measures what we normally call heat radiation. It's not heat radiation, it's radiation from warm bodies.
Right.
So it's sensitive to that. A body, well, we're radiating infrared radiation right now. And that's what Spitzer is good at, is finding the warm dust around stars. It's where it's been especially productive.
So how long, Chandra's still going. You were telling me, it has an unusual orbit. The Hubble's just 300 miles above the Earth, just kind of going around and around. It's a circular orbit, but not Chandra.
Chandra has an elliptical orbit, and this is by design because once Hubble was up there, they said it really costs a lot to service Hubble. We're not going to service Chandra.
Well, I was going to ask you, because Hubble, we've actually sent rockets up to service it.
It's a good thing they could service it, actually.
Right.
And they said, well, this was good. We did a great job with Hubble, and it's a wonderful telescope, but we're not going to do it again with Chandra. We're going to put it up in an orbit where you'll never be able to service it.
So that was a selling point? Is that you can't,
and they said, and we protested, but then got to thinking about it. It's not such a bad idea, because if you get up 6,000 miles above Earth, there's a lot less junk there. It takes a long time, 55, 60 days to make an orbit. You're out of the interference of the shadow. The telescope itself is not getting cool and hot. So it turns out to be a very benign orbit, and it leads for high productivity because you can observe almost all the time. You're not in the shadow of the Earth.
So it goes 60,000 miles away from Earth.
Yeah, maybe 85,000. Really.
And then comes back and comes close to Earth.
6,000 miles. Never close enough to be serviced.
Right, but close enough to send data back.
It sends data back to one of 3 receiving stations on Earth. And so depending on conditions, it'll download the data to a place in the Pacific, or a place in Spain, or a place here at Goddard Space Flight Center in the U.S.
Must be wonderful for astronomers to be able to observe phenomenon that they've theorized or thought about, but actually see it, things like the merging white dwarfs and things like that, and actually see the results of those in action.
Yeah, that is fantastic, that some things that people had thought of, they thought, well, maybe we'll see this and maybe we won't.
Right.
The universe is so rich with phenomena. You can almost count, if you think of it, it's out there.
Something's going on.
Yeah,
you obviously aren't going to be able to watch this mechanism. Probably takes millions or trillions of years, but you could see each stage of it by looking around.
Well, do you worry? I know you said it's in a benign orbit. Do you worry about it not being serviced, that it won't last?
Well, that's definitely a concern. If something goes wrong, it goes wrong. So we had to be extremely careful in making it. And although, for example, one thing that sort of went wrong was that when they first launched it, they began to see noise that they didn't know where it was coming from. It turned out that the mirrors would also reflect protons. And so when it came through the radiation belts, it was damaging the detector.
Ooh.
And everybody was in a panic state at that point. But then they thought about it. They did some tests in the laboratory. They keep a mock-up of the very same thing. They said, well, we just shut the detector, not the telescope, but we close off the detector when we go through the radiation belts, and we open it up again. The problem solved, really. So,
how long did it take to design the Chandra? Was it a decade-long process?
Yeah, it was a decade long. I mean, the original idea was broached in the late 60s with a very detailed thing. The funding wasn't there, and in a sense, it's maybe good because the technology has improved. And it really got going in the late 80s. They started really fabricating it and testing it. They had to do test things because there was still a lot of skepticism that you could build a telescope that would reflect X-rays and focus them as well as they claimed Chandra would. So they did the tests. passed the test. They says, all right, you got to go ahead. And so it was launched in 1999.
And it's been up there ever since, transmitting and doing its job.
Yeah,
and
very
you
well.
said maybe another 5 years?
Maybe more.
Maybe
hope.
more.
Yeah.
Let's keep it going. Yeah. The smoothest mirror ever made.
Yeah.
Really amazing technology, and just amazing images. And you can read it all in the book. Just came out from Smithsonian Books. It's Chandra's Cosmos, and our guest has been its author, Wallace Tucker. He's an astrophysicist and the author. And boy, it's really a great book because it's loaded with illustrations. Some are artists' conceptions, and some are just recolored images directly from Chandra, which is, it's pretty amazing when you see these images. You're looking at the creation of the universe, the result of the creation of the universe, distant bodies, all sorts of things. As you say, was it the big, the beautiful, and the ugly?
No, the bad.
The bad.
The black hole that
like
suck everything in.
There's no ugly here. Wallace, thank you so much for joining us. I
My
really
pleasure.
appreciate
Enjoyed
it.
it.
Thank you for the
Thank
book. I
you.
encourage everybody to take a look.